Hello everybody, welcome to my presentation on Amazon S3 and Redshift. Amazon Redshift is a fully managed petabyte scale data warehouse solution that makes querying your business data simple, integratable, and scalable. Redshift's great advantage comes from its columnar storage of data. MySQL databases, for example, store data in rows. This means each entry is stored sequentially after one another. While this makes row retrieval easy, it's slow for column-based computation. Redshift shines when column-based full table length analysis are frequently used in production, for it groups the same types of data together in memory. Redshift databases can be accessed through various client applications. This simplifies the client-facing user experience by querying this sharded database using a regular SQL-like language. Even though Redshift data is sliced, the user querying the data does not need to deal with that complexity. When a user writes a query, a leader node dispatches the query to each slice of the data and runs the query in parallel, thus greatly increasing the speed at which data is returned. So let's talk about how to set up a Redshift cluster, how to load data into it, and how to query it. Create an Amazon Web Service account. If you have one, navigate to your user console and select Redshift. In the Redshift homepage, select Clusters on the left-hand navigation panel and click Launch Cluster. You'll be prompted to create a name for your cluster, to pick a region, and to pick a size. Once you set your configurations, click OK, and then click on your cluster name. When you click on your cluster name, select the Configurations tab. Here, we will be able to set a security group that can access this cluster. Click on the VPC security group, and you'll be taken to a window like this. In the bottom Inbound tab, make sure that the type of traffic, protocol, port range, and source are as below if you want to be able to access your Redshift cluster from any IP. If you want to limit your IP access, you can do that here by specifying what source you would like. Back to the cluster configuration page. Here, you will see the master username that you use to create this cluster. You will need this and the JDBC URL when accessing your cluster through SQL Workbench. Now let's talk about using SQL Workbench to connect to your cluster. SQL Workbench will help make your queries manageable, visualizable, and easier to read and write. So go to www.sqlworkbench.net and download a current stable build. They have both versions for Mac and Windows. You'll also need to download Amazon Web Service Redshift drivers to enable SQL Workbench to talk to your cluster. So here's the link. Go ahead and select the 4.1 compatible driver and save it somewhere that you can access later. Go into your file systems and launch SQL Workbench. You'll see their standard home view. It looks like this. As you can see, there's no connection yet, so we'll have to create a new connection. Select File and New Window, and you'll be prompted with a dialog box that looks like this. In the upper left, select New Profile. You can name your connection, and then click Manage Drivers. You'll see this overlaid dialog window. Browse your file systems for the Redshift driver that you just downloaded. The class name should automatically populate, and you can leave the sample URL blank. Click OK. Now you'll need to populate a URL at which this connection will be made. You can find that in the cluster configurations under JDBC URL. Furthermore, you'll need to populate into username and password the master username and password that you set when creating your cluster. Now click OK, and you should see that your connection has been made. Up to this point, all you've done is connect to the cluster. You haven't added anything to the cluster yet. So the next two things we'll do is to create a table and a database and then load into it data from a public S3 bucket. You can create a table in Redshift using the sample queries I've included in the zip folder. But as you can see from the sample, the create table statement is very similar to that in MySQL. However, there's one key difference. Instead of specifying a primary key, we specify a distribution key and a sort key. This key will be used by Redshift to shard the data into different places in memory. Ideally, you want to pick a distribution key that is commonly used as the join column. This way, when your queries are dispatched and joins are necessary, the joins can be executed on the same machine without data being pulled from disparate parts. Now that you've created your table and database, it's time to load into your table some data. The great thing about Redshift is because it's compatible with S3, you can copy directly from any S3 bucket to which you have user access. Up to this point, we haven't created an Amazon Web Service user, so let's take a quick detour to go through that now. Because you'll need those credentials to copy from an S3 bucket, even a public one. So, in order to create a user, you need to go to console and IAM. In the left-hand navigation panel, select Users and select Create New Users. Here, I'm choosing to create 3 new users at once. Make sure you select Generate Access Key for each user and click Create. You'll be prompted to download the access keys. Please do so and put them somewhere safe. This is the last time you'll have access to them. Next, you'd want to grant these newly created users policies that allow them to access your Redshift cluster. You can do that by clicking on the username under Users and clicking Attach Policy. Search for the Redshift All Access policy and grant it to them. Now you're ready to use your copy table statement and to populate your data into your Redshift tables. It may be the case, and it's very likely the case, that you're interested in using data in your own S3 buckets. So now I'm going to talk quickly about how to create an S3 bucket, populate it with data, make it accessible to Redshift, and then the process of copying is same as the one that you see here. So in order to create your own S3 bucket, navigate to the console, select S3, and select Create Bucket. You'll be prompted to come up with a name. Make sure you select a region that is the same as your cluster. Now you can load into your bucket different data files. Here I'm loading in some patent data. Now for the tricky part. We want to grant public access or limited access to this bucket. In order to do so, you have to click on the bucket, click Properties, and under Add Policies, create a policy like this. You can use the AWS policy generator to help you create this JSON.